So the topic for today is solving systems of equations using matrices. And the type of matrix that we're going to use today is something called an augmented matrix. Matrix row reduction is just another method for solving systems of linear equations. And so in this first example, I have a system of linear equations. So 3 equations with 3 variables. And what I'm going to first do with this is I'm going to rewrite this system as a matrix. Now this is very easy. Before I do this, I want to make sure that my 3 equations, or however many equations I have, are lined up the same way. So in other words, all the x terms are vertically aligned, all the y terms are vertically aligned, all the z terms are vertically aligned, all the equal signs are vertically aligned, and then the numbers on the right hand side of the equation. And here's what I'm going to do to write this as a matrix. All I'm going to do is use the numbers in front of the variables. So my first row is a 2, a 1, a 3, and a 9. See, 2, 1, 3, 9. My second row, my coefficients are 1, -2, 1, and 8. 1, -2, 1, and 8. -4, 3, 2, -4. So here you see -4, 3, 2, -4. So that's what I've done, is write this as a matrix. And now I'm going to do matrix row operations. And what I'm going to do is essentially convert this matrix into a matrix that's going to give me the solution to this particular system. So my second step is to perform a matrix row operation, all right, with the goal of making 2 zeros in the same column. So if you recall, when we learned how to solve systems of equations like this before, we used elimination, and we tried to eliminate one of the variables so that we would make 2 equations that had the same 2 variables. We are doing the same thing. We are going to get 2 zeros in the same column so that we have 2 rows with the same 2 variables represented. All right, so we're going to start with our matrix, our very first matrix that we started with, and what we're going to do is we're going to try and get a 0 here. And ultimately, we want 2 zeros in the same column. And what I'm going to do is I can multiply a row by a number, and I can add 2 rows together. So here's what I've chosen to do. So my row operation is 4 times row 2 plus row 3, and what I'm going to do is I'm going to replace one of my current rows with the answer to this calculation. And what I'm going to do is put it in row 3. So what this row operation means is multiply each value in row 2 by 4 and add it to the value in row 3. So it's just like taking the second equation, multiplying the second equation by 4, and then adding it to the third equation. And when we do that, what ends up happening is our x terms will eliminate. And what we're going to find is we're going to get a 0 in an x position. All right? So in order to create a 0 here, I'm going to multiply the second row by 4 and add it to this row. So 4 times 1 plus -4 is going to give me 0. And I'm going to put that in my third row. -2 times 4 is -8. Plus 3 is -5. That goes in my third row. 4 times 1 is 4. Plus 2 is 6. The 6 goes in my third row. 4 times 8 is 32. Plus -4 is 28. And that goes in my third row. And my first 2 rows stay the same as they were in the previous matrix. They do not change. All right, but now I have a 0 here. So I want another 0 here. So what I'm going to do is multiply this second row by -2 and add it to the top row. So my row operation that I'm going to use is -2 times row 2 plus row 1, and I'm going to put it in place of row 1. So -2 times 1 is -2, plus 2 is 0. And here's what I'm going to do. Whoops, let's try to get this all on the screen. Here's my 0. It's going in row 1. -2 times -2 is 4, plus 1 is 5. That goes in row 1. -2 times 1 is -2, plus 3 is 1. And that goes in row 1. I've got -2 times 8 is -16, plus 9 is going to give me -7. And that goes in row 1. And here's what you notice. These two rows, carry them over to the next matrix. All right, so all I did was elimination. I'm just writing it a different way. So I carried those bottom two rows to my next matrix. Now, I have two equations, row 1 and row 3, with the same two variables, y and z. I need to eliminate one. The obvious choice is simply to add row 1 and row 3 together, because that's going to eliminate a y, and I'll get a 0 there. All right, so when I add row 1 and row 3, I either want to put my new row in row 1 or row 3. So I just choose row 3. You could choose row 1. It does not matter. All right, so now I'm going to do this again. And notice, row 3 is the only row that's going to change, because that's what I'm putting something new into. Row 1 and 2 actually carry over to my next matrix. I'm only changing one row. So here, add row 1 and row 3. 0 plus 0 is 0. 5 plus -5 is 0. 1 plus 6 is 7. -7 plus 28 is 21. And here's what I have now. I have something called a triangular matrix. Remember when we used to say we were looking for a triangular system? Well, I have something triangular. I have one row with just a z, one row with y and z, and one row with both x, y, and z. They're just in mixed up order. The great thing is now I just rewrite these as equations. So this is 5y plus z is -7. This is x minus 2y plus z equals 8. This is 7z equals 21. Because remember, these are just x coefficients, these are y coefficients, and these are z coefficients. There is an equal sign here, and this is the number on the other side of the equal sign. So now, all I have to do is simple substitution. First of all, if 7z is 21, divide both sides by 7, and I get z is 3. Go to your top equation. Substitute in 3 for z. So we get 5y plus 3 equals -7. Subtract 3 from both sides, and you get 5y equals -10. Divide both sides by 5, and you get y is -2. Now we're going to take y and z, put them into this equation. You did this before. This is just simple substitution. So I've got x minus 2 times -2 plus 3 equals 8. So this is x plus 4 plus 3 equals 8. This is 7, so subtract 7 on both sides, and I get x equals 1. Done.
All right.
So now, let's turn the page and we'll do this again. Now keep in mind, I've got some row operations written down here for us to use, but each of us may do this differently. So as a result, you're all going to end up with the same answer because there's only one answer to this. But your work along the way may be different, all right, depending on what you choose to eliminate. So first of all, I've got this system of equations. My first job is rewrite it as a matrix. So I'm going to go and look at all my coefficients. I've got a 2, -1, -1, and 2. So I'm going to write that in as my first row. The second equation, my coefficients are 1, -5, 3, and -13. All right, my last equation, my coefficients are -2, -2, 1, and -2. All right, I'm going to need to eliminate something. If I look at my first row operation that I have written here, I'm taking row 1 plus row 3 and adding them together. And I can tell by looking at this, that's going to eliminate for me an x. All right, so I must be trying to eliminate x. Now, row 3 is the only row that's going to change here. Row 1 and row 2 are just coming over here the way they are. So I'm going to go ahead and write them in. So this is 2, -1, -1, 2, and 1, -5, 3, -13. Now I'm going to add row 1 and row 3 and put those numbers in this row. So 2 and -2 give me 0. -1 and -2 give me -3. -1 and 1 give me 0. Bonus! Got an extra 0. And 2 and -2 give me 0. Now the interesting thing about this is this actually tells me that -3y equals 0. If you divide both sides by -3, you get y equals 0. So we already know y is going to be 0. We got that from this information. But our matrix is still incomplete because we can't get x and z here. So the next thing I'm going to do is I've got a row operation that says -2 times row 2 plus row 1. So I can tell that my goal here is to eliminate an x. All right, and I'm going to put this, I actually have in here, in row 2. It doesn't matter, I could put it in row 2 or row 1. Does not matter. So if you do it differently, you'll have different equations to work with in the end, but you'll still come up with the same answer. So only row 2 is going to change. So I'm going to write, and now keep in mind, row 1 and row 3 come from here, not here. They come from here, the matrix I just used. So this is 2, -1, -1, and 2. And this is 0, -3, 0, and 0. All right, so -2 times row 2. So -2 times 1 is -2, plus 2 is 0, so that goes here. -2 times -5 is 10, plus -1 is 9. -2 times 3 is -6, plus -1 is -7. -2 times -13 is positive 26, plus 2 is 28. All right, now I'm done using the matrices, and the reason why is because, look, I have one equation with all 3 variables, one of them with only 2, and finally, I have one equation with just one of the 2 that were in the previous equation. So now I can write this as a system of equations. The 2, -1, -1, 2 means 2x minus y minus z equals 2. The 9, negative 7, and 28 means 9y minus 7z equals 28. Then I have negative 3y equals 0. And remember, if I divide both sides by negative 3, I get y equals 0. So I know already that my y value is 0. So I'm going to write that one in. Now go to that middle equation and we'll solve for z. So I've got 9 times 0 minus 7z equals 28. That gives me negative 7z equals 28. Divide both sides by negative 7 and I get z equals negative 4. So let's write that value in. Now I'm going to go to that top equation with x, y, and z. And I'm going to fill in y and z to solve for x. So I've got 2x minus 0 minus negative 4 equals 2. All right, so this is 2x plus 4 equals 2. Subtract 4 from both sides and we get 2x equals negative 2. Divide both sides by 2 and we get x equals negative 1. Simple substitution at the end. All right, let's do this one more time. All right, this time, if you look at this system, some of the variables are not represented in every equation. This is fine. First thing I'm going to do, let's rewrite this as a matrix. So my first row is 2, negative 1, 3, 5. My next row is 4, 1, 0, 13. Here I have 3, 0, 4, 4. Okay, now what I want to do is I want 2 zeros in the same column. So the smart thing to do is actually use a 0 that I have already and make another one in that same column. If I look here, mathematically this is a little hard to eliminate another z because I have a 3 and a 4. But here, all I have to do is add row 1 and row 2 and I get another 0 in that column. So that's what I'm going to do. I'm going to add row 1 plus row 2, and I'm going to put it in place of row 1. And there's a reason I chose row 1. I chose row 1 because row 1 didn't have any zeros in it. Row 2 has a 0, and my goal is to get zeros, so I don't want to blow that row away. I'm just going to leave it there. I'm going to blow away a row that doesn't have any zeros. All right? So that's my first task. So row 1 plus row 2. So in other words, my second and third rows, just copy them over. So this is 4, 1, 0, 13, and 3, 0, 4, 4. Now add row 1 and row 2. 2 plus 4 is 6. Negative 1 and 1 is 0. 3 and 0 is 3. And 5 and 13 is going to give me 18. All right. Now, I don't really have enough right now to end because I need one or the other of these 2 rows that have the zeros in the same column to have another 0 somewhere. All right, so I either want a 0 in the z position or a 0 in the x position. And I'm looking at this thinking I would rather work with 3 and 6 than 3 and 4. Because to work with 3 and 6, I can just multiply row 3 by negative 2. Then I have negative 6 and 6. So my row operation is going to look like this. It's going to be negative 2 times row 2. Now I've got to add it to row 1. Oh, I'm sorry, row 3. Row 3. And add it to row 1. And I got to put this either in the first or the third row. And I think what I'd like to do is I'd like to put it in the first row because it has bigger numbers. I'd rather keep the smaller numbers because smaller numbers are easier to work with. So I'll just put it in the first row. If you want to put it in the third row, totally fine. Nothing wrong with that. So I'm going to put it in the first row. And I'm going to draw a matrix. So now I know only row 1 is going to change, so I'm going to draw in row 2 and row 3. So I've got 4, 1, 0, 13, and 3, 0, 4, 4. So 2 times row 3, so negative 2 times 3 is negative 6, plus 6 is 0. That goes here. 0 times negative 2 is 0, plus 0 is 0. 4 times negative 2 is negative 8, plus 3 is negative 5. Sense a need for a calculator coming up. I've got negative 2 times 4 is negative 8, plus 18 is actually going to give me 10. Now I have a system of equations here that I can actually solve, because I can solve for z here. I can put that value of z in here and get my x value right here. So let's go ahead and convert this matrix into a system of equations. So first of all, this is negative 5z equals 10. This is 4x plus y equals 13. This is 3x plus 4z equals 4. All right, first of all, take this equation, divide both sides by negative 5, and you get z equals negative 2. All right, so z is negative 2. Let's go ahead and put z in here and solve for x. All right, so I've got 3x plus 4 times negative 2 equals 4. So this is negative 8, so add 8 to both sides. And I've got 3x equals 12. Divide both sides by 3, and I get x is 4. All right, now take your x, put it in the second equation, and we'll solve for y. So I've got 4 times 4 plus y equals 13. This is 16, so subtract 16 on both sides, and I have y is negative 3.